Hello, myself. I am R. Banjan. Today's course will be the only limit of realization of tomorrow will be our doubts of today, said by Franklin D. Roosevelt. The future will be belongs to those who believe in the beauty of their dreams, said by Eleanor Roosevelt. I am hello myself. I am R. Banjan. Uh, Today, today the course will be the only limit to our decision of tomorrow will be our doubts of our today, said by Franklin D. Roosevelt. And those who believe, see, the future will be belongs to those who believe in the beauty of their dreams, said by Eleanor Roosevelt.
Magnetic circuits. Suppose I'm having a coil. Coil means it is nothing but a conductor, but it has a coating, insulation coating. If you pass current through this structure of I, then it will produce magnetic flux. It will produce magnetic flux like this. The strength of this magnetic flux is 5 Webers. Current is I. The number of windings equal to N. Therefore, the number of flux linked with that coil is lambda equal to N times 5. The flux can also be talked in terms of current. That is, N is lambda is proportional to I, or lambda equal to L times I. Let it be 1, let it be 2. Equating 1 and 2, we'll get N phi equal to Li, where L is the constant of proportionality called inductance. Or L equal to N phi by I. Where L equal to N phi by I, where phi is the amount of flux in Webers, where N is the number of turns, I is the current through the coil. What is the voltage across this coil? V. For constant current, there won't be any voltage. But for any change in current, there will be induced voltage. Or change in flux, induced voltage. That is called V equal to d lambda by dt. d lambda by dt. That is equal to d by dt of N phi. That is equal to N into d phi by dt. That is the voltage across the coil V. Rate of change of flux. The same way, V is also equal to L di by dt. V also equal to, if current changes, flux also changes. That's why we can say voltage across the coil V equal to L into di by dt. Therefore, N d phi by dt equal to L di by dt. Or we can say that L equal to N d phi by dt. This is in volts divided by di by dt, rate of change of current. For a production of 1 volt, the voltage across the coil is 1 volt. For a current change of 1 ampere per second, then this inductance is 1 Henry. That is the definition for unit of inductance. Here L equal to N into d phi by dt divided by di by dt. So it can also be written as L equal to N d phi by dt. This denominator can be written as dt by di. dt upon di. dt getting cancelled. Therefore, L equal to N into d phi by di. This is another definition. Change in flux with respect to change in current. That is also inductance. That is also inductance. Suppose I'm having one coil. This is coil number 1. Current through this coil is I1. Flux developed in this coil is phi 1. Another coil is there. It is wound on the core, iron core, let us assume. So flux produced by this coil interacts with the second coil. Even if it is in air, then also it interacts. Even if it is in air, then flux produced by first coil linked with the second coil. Linked with the second coil. So flux produced in the first coil is phi 1, 1. This first one indicates that first coil. The second one indicates that I1. This flux linked with the second coil, the amount of flux linked with the second coil is phi 2, 1. This 2 represents second coil. This 1 represents I1. The flux produced by I1, but it links with the second coil. Linked with the second coil. But not all fluxes linked with fluxes produced by first coil. Not the entire flux linked with the second coil. Some part of flux is linked with the second coil because some of the fluxes will escape the path and flow like this. That's why some 80% of fluxes linked means so K equal to 0.8 we say. So that is called coefficient of coupling. How much flux produced by the first coil linked with the second coil. Similarly, if current flows through this is I2 means second coil also will produce flux called phi 2, 2. It linked with the first coil. That is phi 1, 2 because of current 2. So this phi 1, 2 is flux produced by second coil linked with the first coil. Phi 2, 1 is flux produced by the first coil linked with the second coil. Phi 1, 1 is flux produced by the first coil because of I1. Phi 2, 2 is flux produced by second coil because of current I2. Now, what is the total flux in the first coil? Total flux phi 1 in the first coil is phi 1, 1 plus phi 1, 2. Similarly, total flux in the second coil is phi 2, 2 plus phi 2, 1. Number of, if you want to find the how much flux linked with the first coil, how many turns are there? N1 turns are there. The amount of flux linked with the first coil equal to N1 phi 1, 1 plus N1 phi 1, 2. Similarly, amount of flux linked with the second coil is N2 phi 2, 2 plus N2 phi 2, 1. This is equal to what? This is because of self-inductance L1. This is because of self-inductance L2. But what is this? This is also flux from the second coil linked with the first coil. This is flux from the first coil linked with the second coil. That's why this flux also have the same effect like L1. That's why the lambda 1 can also be written as L1 I1. L1 I1 plus this is because of I2. This flux is because of I2. But it is not because of L1. Another inductive effect because of flux linked with the first coil. That's why this can be called as M12. Similarly, how much flux linked with the second coil is L2 I2 plus M21 I1. What is the voltage induced in the first coil? V equal to derivative of rate of change of flux. That is N1 d phi 11 by dt plus N1 d phi 12 by dt. This is V1. But if you differentiate this, you will get V1 also equal to L1 di1 by dt plus M12. M is mutual inductance. Because of flux, this constant is because of flux from the first coil. Flux from the second coil. di2 by dt. Similarly, we can write V2 equal to N2 d5 22 by dt plus N2 d5 21 by dt. This is also equal to L2 di2 by dt plus M21 di1 by dt. This M21 and M12 are equal. M12 equal to M21 can be called as M, that is called the mutual inductance. This flux produced by second coil may aid or oppose. That's why this M may have plus or minus. This M also has plus or minus. So the value of M may have positive or negative. Positive means it aids the original flux in the first coil. Similarly here, the M may have positive or negative value. Positive value means it aids the flux in the second coil, or it may oppose the flux in the second coil. How to find whether it opposes or aids, that we will see later.